That is what the meaning. Okay. So entropy, that is 1-2 formula already we studied. That is entropy. There were so many formula if you talk about entropy. So entropy change, we have mentioned entropy change by delta S. Okay. And if you defining this one, so how you are defining, it is measure of randomness of system. Here I am writing, it is a measure of, it is a measure of randomness of the system. Randomness or disorder of the system, or disorderness of system. That is what study we study of system, that how much system is disorder. Okay, this is all about the second law of thermodynamics. Okay, so second law of thermodynamics is dealing that, saying that is whether the reaction will be the forward or the reverse one. Okay, so here the entropy, the formula number 1 I told you, that is delta S is equal to, okay, Q reversible upon temperature. This is one. Second one I told you, that is already we have done the problem, delta S is equal to delta H, vaporization, okay, upon the temperature. Okay, TB, boiling point. Vaporization means at the boiling point it is getting vaporized. Next one, if you are talking about, that is third one, delta S is equal to or the enthalpy of reaction is equal to delta S product, that we have to write delta S product minus delta S reactant. Okay, this was there. One more was there. Fourth one, delta S system. So if you are writing delta S system means, if you are total better you write that the correct one is the total entropy, delta S total. Okay, so delta S system, it is going to be delta S system plus delta S surrounding. Okay, so this is all about the formula of the, that is what is called, that is entropy. Okay, 4 formula are there. So this formula and this formula already we studied yesterday, and today we are going to study this one. Okay, so we are going to solve some more problem based on it. So let's try to write the one problem based on it. The question here I'm writing, they are saying determine the entropy change for the reaction. They are saying determine the entropy, change for the reaction. Okay, so what are the entropy change for the reaction? Here is they are saying that is 2H2 gas, it is converting in, reacting with O2 gas, it is going to be 2H2O, this is converting into liquid at 300 Kelvin temperature. They have given 300 Kelvin. Now they are saying if standard gives free energy, some value are given. If standard gives free energy, standard entropy, not gives free, standard entropy of H2 gas, comma O2 gas and H2O liquid are how much it is, that is 126.6 comma 201.2 and how much is there, 68, this is there 68 joule Kelvin inverse and mole inverse respectively. So they are asking this one. Okay, option also they have mentioned how much, 218.4, 318.4, this is the plus, minus 318.4 plus 218.4. They have given the 4 option. Now see the reaction is given. Okay, so we have to apply, that is entropy of reaction. So entropy of reaction means this can be the, this is the only
Yes,
product and reactant are mentioned. So this is what entropy of reaction. So This is ENTR, entropy of reaction. So we have to apply this one. Okay, entropy of reaction. So let's try to follow out this one. Okay, so if you are talking about this one, so I'm writing solution. What is there? 2H2 gas, okay, plus this is the O2 gas. It is going to give, that is 2H2O liquid, right? So delta G, not delta G, entropy of reaction, we are going to calculate delta S, na? So delta
Yes.
S reaction. So delta S reaction means product minus reactant. So delta S product minus what we have to write? Delta S reactant. Okay, reactant.
Yes.
So here delta S product is what there? 2 into entropy of H2O, we will write liquid, minus what will be there? That is here the summation bracket, 2 into entropy of H2 plus 1 into entropy of what is, that is O2. Why we are taking here 2? Can you please tell me here 2H2 and 1S, 1 entropy O2? Because
Yes, sir.
here in the coefficient is how much? 2. Here is 1. Here is 2. So we have multiplied. Will it be clear to you?
Yes, sir.
So kindly make a
Yes, sir.
okay. So I am mentioning here, that is entropy of H2O they have given. What is this? Is the H2 value. The H2 is the first one, I think. Then O2 201.2. Then H2. H2O is 68. So I am writing that is here is 68 minus. So here you see what will be there? That is 2 into H2. H2. So H2 value, how much is there? H2, the first one is H2. So H2 is 126, 126.6 plus. It is there, O2 is there. So only one O2 is there. So this is the O2 value. So 2 not 1.2. 2 not 1.2. This is the value. Now let us try to understand here. So delta S reaction is equal to, you multiply this one. So 2 8 ja 16, 2 6 ja 12, 113, 136 minus. Bracket we have to solve by multiplying this. So can you multiply this one? How much you are going to get here? 2 6 ja 12. Okay. So there again there is 2 6 ja 12, 113. 2 2 ja 4, 1 5, 2 1 ja 2. So
एक टाइम में आ जाते हैं मगर
253.2, and here is the positive one. What is there? 201.2. Okay, this is there. Now add it out. So it is giving 136 minus. We need to add it out. So that is 2 2. It is going to get 4. Here is how much is coming? 31450. It is going to be 5 and 224. This is coming now. See, so 454.4 minus 136, 136.0. Okay, so this is going to be 4, and here is the 14 minus 6. This is going to be 8, and here is the 4 minus, that is 3. So 1, and here is the 4 minus 318. Any option is there? So it is going to be minus 318.4 delta S reaction. RB kilojoule per mole. Why? Because here unit are there. Joule Kelvin are there. No? Joule Kelvin. It is also will be the Joule Kelvin. Janab, is it clear to you?
yes sir, yes it is.
Okay, thank you very much.
Sir,
Okay,
I'm writing one.
no issue. You can write, please. If it is done, please tell me now.
Yes, sure, sir. Just wait 2 minutes.
Mhm. Done.
Yes, sir, done.
Okay. One more question I'm writing. You also try to solve that one. Let's write down this one. Okay. This question is there. They are saying calculate the change in entropy for following reaction. Calculate the change in entropy. Calculate the change in entropy for the following reaction. Okay, so here is that they have given 2CO gas plus O2 gas. It is going to be 2CO2 gas, right? This is there. Now they have given as entropy of CO, they have given 197.6, and then they are talking about SO2, they have given how much? 205.03, and SCO2 they have given how much? 213.6. This is now they are saying Joule Kelvin. This all our value are there. Joule Kelvin inverse and mole inverse. They are saying. So calculate the change in entropy of the following reaction. Option they have given. A number. What is their A number? Minus 273.03. B number they are saying minus 373.03. C number plus 273.03. And D number they are saying plus 373.03. These are the values are there. No. These are wrong. Somewhere I mentioned wrong. Minus 1 is there. This is 173.03. So let's try to solve it out. How can you be able to solve this problem? If you see, so the reaction has given here. This is the reaction. Okay. So entropy of the reaction, how we are calculating? The entropy of product minus entropy of reactant. That is the what simple formula. So entropy delta S reaction, if you are talking about, so this is going to be delta S product, right? And minus delta S reactant. This is what. Now you see delta S product, how much is there? So product is how much is there? 2CO2. So 2 into delta S CO2 minus what are there? That is 2 are there. So I know middle bracket I have taken 2 into okay delta S okay CO plus delta S O2. This is there. Now you can see here what CO2 value they have given. CO2 value this one. So 213.6 minus we have to solve the bracket plus 2 into CO. CO is how much? 197.6, and again what there SO2 O2 is there. So O2 value is there 205.03. Okay, so you solve this. So if I'll multiply it, to what will coming? 2 6 ja 12. Okay, carry 1. 2 3 ja 6, 1 7. 2 1 ja 2. 2 2 ja 4 minus. Okay. point will be here. Okay, minus. Let us solve. 2 6 are 12. 2 7 are how much is coming? Let's try to solve. Use the calculator first. Okay, so it is 197.6 multiplied by 2. So 395.2. You know, this is coming 395.2 plus 205.03. Solve it. So 395.2 plus how much we can do?
Yes, sir.
205.03, that is coming. So here is that is 427.2 minus 600.23. So you can subtract it out. So 427.2. So 173, it is coming negative of 173.03. It is coming, that is joule, Kelvin inverse, mole inverse. So our option, correct option is option number C. So you need to be very, very careful while doing the calculation portion. Is it okay? Is it okay? Can you understand this one, Janam?
Sir.
Okay, please make a note of it. Done? Done?
No, sir.
Over? Written? Can I erase?
No, wait.
Okay, okay, okay. So my network issue is coming. Hasa, your mobile is connected? Is it audible, Jana?
Yes, sir. Yes.
Here is disconnecting.
Yes, sir. It is. Hello.
Ah, yeah, listening, listening.
Done, sir.
Okay, thank you. Okay, now changing this one. Now that is entropy in reversible process. Okay, entropy in, okay, uh, reversible expansion of gas. Reversible expansion of gas. Okay, this is what the one last one is there, based on the no problem based on entropy. So they are saying entropy in reversible expansion of gas. Okay, so how can you be able to understand for this one? Okay, so how they are saying that is, if you are expanding the gas, they are saying that is, suppose the one container is this one, and you are reversibly, here is the piston is there, up to the piston is up to that is what. Okay, now what is the what is happening here, you can see this one. So expansion, if you are expansion, so they are saying if you are expanding, the entropy has to increase. So they are saying that is how much expansion, this much, the piston goes to here. Okay, now this is, yeah. So now you see, they are saying that is entropy in the reversible expansion. So how we calculate delta S? Okay, reversible expansion. So this is minus 2.303 nRT log V2 upon V1. This is the first one. Okay, that we need to keep in mind. Okay, there's only in the NEET or JE this is there in the syllabus, this one more is there, one possibility is reversible and expansion. If you are talking about, so minus 2.303 nRT log P1 upon P2. In the term of pressure, it is going to be P1 upon P2, but when you are talking about in the term of volume, it will be V2 upon V1. That you need to keep in mind. Why this is changing pressure and volume, the formula P1 P2 and V2 V1. So you know P1 V1 is equal to P2 V2, right? So if you are changing V1 this side, so P2 will come this side. So P1 upon P2 is equal to V2 upon V1. So because of this one, P1 upon P2 is equal to what? V2 upon V1. So this one is the, okay, at the place of V2 upon V1, if you are placing, so it is going to come P1 upon P2. So this is entropy in reversible expansion of the gas is minus 2.303 nRT log V2 upon V1. Can you be able to understand this one formula? No.
Yes, sir.
Okay, so I am writing the questions here. You try to see what the question is all about. You try to solve the problem based on it. I'm giving you here what is they are saying. Calculate. Here is what they are. Calculate
Yes, sir.
the entropy. Calculate the entropy change. Calculate the entropy change when 2 mole of N. This is the ideal gas. 2 mole of an ideal gas expand, okay, expand isothermally. This is what isothermally, okay, and reversibly, and isothermally and reversibly from an initial volume, from an initial volume. I wait from an initial volume to initial volume of 2 decimeter cube, 2 decimeter cube to 20 decimeter cube of final volume at, they are saying 300 Kelvin. Okay, so we have to solve this one, right? They have given the option also, even though I can mention the option here is 38 kilo, Joule Kelvin inverse. Here is Joule Kelvin inverse. A number, B number 48 Joule Kelvin inverse. Okay, C number 47 Joule Kelvin inverse, none. Okay, here you can mention that is 49 Joule Kelvin inverse here. So this is what the option they have given. What we have to do, they are asking calculate the entropy change. They are asking entropy change when 2 mole of ideal gas expand isothermally and reversibly. So isothermal reversible expansion of gas, so delta S, okay? If you are isothermal and reversible, both are there. So what, minus 2.303 nRT log, they are saying that is V2 upon V1, okay? So you see here how many mole they have given, 2 mole. So directly I am plugging the value 2.303, n value is 2, r value is given here, r is equal to 8.314, 8.314. So I'm directly mentioning 8.314, okay, here is 2 into temperature, how much they have given, 300 Kelvin, then log value V2 upon V1, this is the final and this is initial. So that is 20 upon, it is going to be 10. This is now if you are dividing this one, so it is 10 times it is going. So log 10 is equal to going to be 1. Log 10 is equal to, let's try to solve it out. So it is minus 2.303 into, you can multiply first and then write. Okay, let it be like. So 8.314 into 600 and log 10 into 1. This is, if you solve this one out, how much is coming here? You see, it is coming 38.294 Joule Kelvin inverse. So this is the delta S is coming. So our required answer is going to be option number 1. Can you please check this one if you can understand this? Yes, yeah, no.
Yes, sir, I can.
Okay, please make a note.
Yes, sir.
Or can I erase and I will send the PDF to you? That also you can do. Otherwise, you can.
Yeah, sir, I'm almost done. Last part.
No problem, no problem. Done.
Yes, sir. Done.
Okay. So let us try to change this one. Next problem we are sending. Now you try to solve this problem and tell me the answers. Okay. Question they are saying. You try 5 mole, 5 mole of N, 5 mole of N ideal gas expands, ideal gas expand reversibly, reversibly and isothermally, and isothermally from a volume of, from a volume of 8 decimeter cube to 80 decimeter cube at a temperature, they are saying at a temperature, at a temperature of 27 degrees Celsius. Calculate change in entropy. Calculate change in entropy. Change in entropy. The point which we have to keep in mind, temperature you need to take in the Kelvin, okay? Because R value they have given, R value they have given 8.314, okay? This one is given, okay? Next one, options are given. How much? 70.20 Joule Kelvin inverse. B number they are talking about 80.55 Joule Kelvin inverse. C number 95.73 Joule Kelvin inverse, and D number 107.11 Joule Kelvin inverse. So these many options are there. You need to solve. Okay.
Yes,
So
sir.
see how can you be able to solve this? So because here the options are there in Kelvin, so temperature you need to change. So what are the point here is there? N value given 5 mole. This is 5 mole. V1 they have given how much? 8 decimeter cube. V2 they have given how much? 80 decimeter cube. Temperature they have given 27 degrees Celsius. You need to change 27 plus 273. So it is going to be what? 300 Kelvin. Okay. So everything is there. You can do here.
Yes, sir.
Delta S isothermal reversible process, already you know, minus 2.303 nRT log B2 upon B1. So here,
Yes, sir.
so here if you are solving, that is minus 2.303 into n value 5, r value 8.314, t value 300 into log what? 80 upon 8. So it is going to be 10. See here, minus 2.303 into 5 into 8.314 into 300 into log 10. Log 10 value how much? 1. Log 10 is equal to 1. So what will be there here? 2 point, minus 2.303 into 8.314 into 1500. So if you are solving this one, how much is coming? It is coming 95.73, 95.73. Okay. These are the options are there in the negative one. These all are their negative option. My mistake here. So minus 97.0, 95.73 Joule Kelvin inverse. So this is the 95.7. This is the option. Correct option is option number C.
Yes, sir. C option C.
Yes. So you can make a note if you want. So other questions are similar questions are there. Can I give you PDF to solve you? Can you solve by your
Yes,
own?
sir. Yes.
So we can change the topic because the last topic is there, gives free energy. Okay. So that will be gives free energy will be the last topic, which is also describing the second law of thermodynamics, or you can say failure of the first law of thermodynamics. Done.
1 minute, sir.
Hmm.
Done, sir.
Done. Okay, good. So I'll give the rest of the problem. You practice by yourself. Here we are going for the Gibbs free energy. Okay, quite good one. This is the Gibbs free energy. If you talk about the Gibbs free energy, okay, this is the Gibbs free energy. So this is also written at delta G. Okay. Now they are saying it is another it is another thermodynamic function. Thermodynamic function. It is another thermodynamic function which what going to do? Which explained explained the feasibility of reaction. Okay, feasibility feasibility of reaction, or weakness of reaction, or the weakness of first law of thermodynamics. Weakness of first law of thermodynamics. First law of thermodynamics. Okay, this is what first law of thermodynamics. Okay, this is what the point. Now,
Okay, sir.
what we can do here, what we can do here, see, if you want to see, they are saying if they are saying delta G, okay, is going to be the negative. Okay, then they are saying process is spontaneous. Process is spontaneous, and spontaneous means feasible. Process is spontaneous, that is feasible. Okay, feasible. Now the next one they are saying
Yes, sir.
delta G if it is coming positive. So here if it is the process is non-spontaneous. Okay, non-spontaneous. This is going to be non-spontaneous. That is here you can see not feasible. That is not feasible. Okay, the process is not feasible. And if delta G is equal to 0, if it is going to be 0, so what you are going to be 0, if delta is 0, so equilibrium. Okay, equilibrium. Okay, equilibrium process. Now this is the another term. Okay, so they are saying it is another thermodynamics terms which explain the feasibility of the reaction or weakness of first law of thermodynamics. So how can you be able to understand this? Let's try to understand. Gives free energy, if talk about gives free energy. Okay, gives free energy. Better the term is standard gives free energy. We have to calculate. Standard means the temperature will be given. Temperature will be given. Standard temperature and pressure, you can say as STP. Standard gives free energy. Okay, so it is maximum. It is maximum amount of energy. It is maximum amount of energy. It is maximum amount of energy which is maximum amount of energy which is used to do useful work. Useful work. Okay, mathematically how they are saying, mathematically it is calculated by Gibbs Helmholtz Helmholtz equation. It is calculated by Gibbs Helmholtz equation. So delta G naught is equal to delta H minus T delta S. This is what. Okay. So that is, if you are talking about, this is change in entropy. This is going change in entropy. This is the first one, change in entropy. Okay, this is the temperature. Temperature in Kelvin. Temperature in Kelvin. Okay. Next one here is change in enthalpy. Change in enthalpy. Change in going to be enthalpy. Last one, change in gives free energy. Change in gives free energy. Change in gives free energy. Okay, this is. So let's try to understand once more. It is maximum amount of energy which is used to do useful work. Mathematically, it is calculated by Gibbs Helmholtz equation. This equation is what? This is what is known as Gibbs Helm. Sometime this equation itself asks Helmholtz equation. Okay, sometime ask itself only equation they ask sometime. Gives Helmholtz equation. So what is there? Delta G naught is equal to delta H minus T delta S. So can you have a note of it so that we can solve some of the problem based on it? Is it?
Yes, sir.
Uh, Done.
1 minute, sir.
Okay, no
Done,
problem.
sir.
Okay. So now let's try to solve some of the problem based on it. What the problem?
Yes,
Question.
sir.
We are solving question number 1. Okay. So they are saying enthalpy and entropy change of reaction. They are saying enthalpy and entropy. Enthalpy and entropy change of reaction. Change of reaction. Enthalpy and entropy change of reaction R. R. How much they are talking about? You know, they are saying 40630 joule per mole. And next one they are saying here is 108.8 joule per mole respectively. They are saying calculate gives free energy, calculate gives free energy and determine feasibility of reaction, determine feasibility of the reaction, determine feasibility of reaction. They are saying and determine feasibility of reaction. So at 300 Kelvin. Okay. So option A they are saying feasible, B number, not feasible, non-feasible, feasible, C number, spontaneous, no, non-spontaneous. They are saying non-spontaneous, and D number, A and C, A and C. So how can you be able to solve here? You see, okay, this problem. Let's try. Enthalpy and entropy change of the reaction are given. So delta H is given how much? 40630. Delta S is given how much? 108.8. Okay. T is given how much? 300. So delta G naught is equal to how much? About what the equation you see? H minus T delta S. So I am putting H minus, okay, H minus T delta S. So enthalpy they have given 40 H minus T delta S. So can you, we can place the value here. So H value at 40630 minus temperature is 300 and delta S value 108.8. So if you solve it, how much is coming here? You see, after solving it is coming 7990. This many things are coming. Okay,
Yes, sir.
7990. This is coming. This is coming joule per mole because other values are there na, joule per mole. So this is also coming joule per mole. Now delta G naught, if you see, so it is the, they are saying here what is there, delta G naught is positive. Delta G naught is what? Positive. So positive means what? It is feasible or non-feasible? Tell me. Positive means not feasible. Not feasible. Okay, is spontaneous or not spontaneous? Non-spontaneous. Not spontaneous. See, I wrote here. Here say this. See, if it is the positive, so what is process is not spontaneous and non-feasible. Non-spontaneous, non-feasible. So here what they have given? Positive, not feasible, non-spontaneous. So option number D is B and C. Can you understand this one, Janab?
Yes, sir.
Okay. Can I share the problem to you to solve by your own, or you want to continue?
No, sir, you send.
Okay, because you one hours continuously watching mobile, na, it's quite difficult for you.
Yes, sir.
Hmm. So can I send you the problem, or should I continue
Yes, sir, you can.
another 10 minutes?
No, no, sir, you send the problem.
Okay, okay. Immediately I'll send. Okay. You
Okay.
first make a note of it, then I'll send.
Yes, sir, thank you.
Hmm. What is the next chapter? You didn't send me, Jana. Which chapter you want?
Okay, sir, sure, sir.
What?
Sure, sir, sure.
Okay, okay, okay.
Done, sir.
Done. So okay, I'll send you the problem, and you also send me that is which chapter you want,
Okay,
because
sir.
tomorrow I'll finish completely, because
Sir,
gives
I'll message you tomorrow.
what?
Tomorrow I'll say you, sir.
Okay, okay, okay. Okay, bye.
Thank you, sir. Bye.